Okay, thanks everyone for coming. This week we'll be covering LaTeX. This is a particularly important type of workshop for people who are going to be doing the report section of like the project, and it's also useful for your assignments as well. This is like kind of industry standard type of like formatting, and it's used quite widely in the research field as well. So yeah, hopefully you guys can, like, after the end of this, get the hang about how to create a document and then start formatting and using it for the future reports that we'll be working on.
So what is LaTeX? For those of you who aren't familiar with it, it's a document preparation system, much like Microsoft Word is a document preparation system. But the main difference between LaTeX and Word is that in Word, you type something and it directly goes onto the document, and it's called what you see is what you get. Whereas in LaTeX, as we'll show you, you sort of type your document out in code and then convert that code into the document. So you're doing things behind the scenes in LaTeX rather than directly editing the appearance of the document. And this might seem a bit tricky at first, but it allows you to have greater control over what you're writing and how everything looks. And as Anne said, it is used in a lot of academic settings because it has a lot of, it's very clean in its appearance and you can have a lot of control over how it looks. And there's also a lot of powerful stuff for inserting equations, tables, figures, all that kind of stuff that you would use for scientific and academic writing. And just as a demo, we've got a LaTeX document on this website called Overleaf. So Overleaf is just a free online LaTeX editor. It allows you to collaborate all together on the same document at the same time. So it's a bit like Google Docs, but I'll show you what it looks like. Actually, I've already got it open. So feel free to click on this link on the GitHub or wherever. And on the left, we've got this code that we'll be editing. And this is how we add information to our document. And on the right, we have what the document ends up looking like. So we can't directly edit the stuff on the right-hand side, but by pressing the recompile button here, we can convert our code into the document. And so just a quick overview of the sort of interface for Overleaf. On the left, we have your files, and that can include any code that you would have, like this main.txt file, which is just the main code for our documents. And you can have another code for a different section of the document. For example, the equations section is in a different document. You can have a bibliography file, which we'll get to later. And importantly, you can have images that are used in your document. So we have an images folder here, and we've directly uploaded to the website this Unimob logo, which is then used in the document, as you can see. So that's where you store all your files, images and code, etc. And below that, we have the table of contents, which is automatically generated when you create your document in the code. And we'll explain more details on that as well, but it comes with sections and subsections, appendices, all automatically formatted in the bottom corner there. And then the edit your document section there, whatever you want to call that, and then the preview of your document. And you press the green button, recompile at the top, to update, to send any updates to your code to change the appearance of the document and see the finished product. And this is just a quick overview of the concepts that we'll be covering, but we'll just jump straight into it then.
Awesome. All right. So first off, how we set up a document, we would normally begin with a command where you would kind of classify the document class. In convention wise, we usually use article. There's a couple of other type of document classes that you can use, like reports and stuff like that. And if you click that web link, it will tell you specifically the other different types of document class.
By the way, Anne, just let me know when you want me to switch to the overleaf, and you can show them stuff.
Oh, yeah.
Just let me know.
Okay, cool. Yeah. So in this case, if we just go into our overleaf and scroll all the way up, the very beginning line is where we kind of define it. Here we've got an article, which is the class that this is. And then we've got 12 point, that's our font size. So we've kind of said by standard that 12 points is our font size for just our normal text. And we've also classified the size of the paper as well as A4 paper. Usually if you're just writing a standard report, like that's kind of all you really need, is that line over there. But obviously you can change it if you want according to whatever you're writing. So yeah. Underneath, if you go back to the, yep. So underneath this, we can also change the layout of our document. So that means that we can change the margins, the sizing of the paper, things like that by using a package. We'll get into a little bit more detail about what a package is, but in this case, we can use the geometry package and define specifically and customize your paper. So here you can see that we've defined the size of the paper to be A4, which you can also do in document class. And you can also change the margins as well. So we can like specifically state that the left margin has to be 20 millimeters or the top margin is 20 millimeters. If you don't define your margins, it will be automatic to what the LaTeX convention is. So in this case, we haven't defined our right or bottom one. And so that means that it will just be an automatic margin. But yeah, that's just kind of like just the basics of how to start up our document and set it up. All right, so I mentioned the term package, but LaTeX is built up of packages. There's hundreds of packages out there, and it all depends on what you need it for. But there are a couple of like conventional packages that we will always be using. If you open up the Overleaf again, you can see here that we've got a collection of different packages, and they all kind of assign to like different types of functions that we might be using. So an example would be if you look at the Xcolor, that's a package to help us colorize text and things like that. Then we've got the AMS math package and the math tools and GenSim. Those are all used in combinations to help us create formulas on LaTeX and things like that. We will provide you with like a little template, and that could help you out with just being able to copy and paste most of these packages, and that should be able to set you up with, well, really creating most of your document. Obviously, if you need other stuff, you can always add more packages into here, depending on what you need it for. If you see that add bib resource, what's that package? Oh yeah, the biblate package there. That's a package for you to be able to include bibliographies. And then that M code package, which is also a quite important one, is one where you can actually insert your MATLAB code into your appendix section, and it makes things a lot easier as well.
Yeah, would you like me to show that? Oh, we're going to show that
Yeah,
later.
yeah, you can scroll down. Oh, yeah, that's true. If you scroll all the way down, you can see there, like if we use that M code package, you can nicely insert your MATLAB code at the bottom like that. And you don't actually need to copy and paste the MATLAB code in. It's all quite automatic, which is really, really cool. All right. Okay. Yeah, I think that kind of covers most of it. Would you like to go to the next slide? Awesome. Okay, so once we've kind of done that, we've defined our document class and then we've added all of our packages that we need in, we can start to begin creating our document itself. So this command here, begin document and end document, is kind of like the beginning of where you would put all of the content of your document in. So if you go in the MATLAB, Overleaf, and as you can see there, we've got all of the packages, and then right where line 29 is, that's where we've begun our document. And it's all of the content is sandwiched in between here. So you've got begin document here, and then all the way at the bottom will be where you end your document. So it's kind of like MATLAB, when you create a function, you would have like the begin of a function, and then you've got the end command as well. And in between that function is all of your actual coding or your content.
Mm-hmm.
All right.
Title page. So the first thing you want to do once you've begun your document is to create a title page. And we're going to run through a couple of the commands that you will find useful for that. So you type \begin title page, and that will create the title page. But it's worth noting that we would need to \end the title page as well. Just like we did with beginning the document, we have to end it. So everything has to begin and end. The line centering here, the \centering, puts the current paragraph into the middle of the page. Like in Word, you've got options to put the text at the left, the right, or the middle. So that's what centering does. It chucks it all in the middle. And what we've decided to do here is include the Unimelb logo. So that just adds a picture with \include graphics. We can set a couple of options inside these square brackets. So in this case, we've chosen the width to be 0.2 times the width of the text. You don't have to type the times. You can just type 0.2 \text width. And LaTeX is very intelligent with automatically inserting the multiplication sign and stuff like that, in terms of you can just write two values right next to each other in the code and it will figure out the rest. So you didn't have to put 0.2 times here. We've put in this unimelb.jpg, and that has to be uploaded to the images file, to the images folder with the correct name in Overleaf, as I was showing you earlier. So up here in images, we've got unimelb.jpg. So if I deleted that image, LaTeX would freak out and it wouldn't know what image it's including. So for every time, I'll go back up to the line in the code. Every time you insert an image and you specify the name of that image, well, you need to make sure it's up there in the image folder. And we've actually set this command here, graphics path, which means that our images are going to be within this folder that we've specified to be called images. I could change that to whatever I wanted, as long as I had a folder with the same name. So if I rename this folder to pictures, then I could put the word pictures here instead. We've put images, and that just means we don't have to type images /Unimelb. We can just type Unimelb directly, and it automatically searches the images folder. So we've got our image in the right spot in the folder, and we've included it. And what we've done here is put some space just after the image with a new paragraph and some vertical space. You can specify how much vertical space you want. So let's go back to the actual title page and have a look. We've got our image, and you can see straight below the image, we've got a bit of space. Now what we've done is added some titles, some text. So \SC shape means small caps text. It's specifying the format of the font, how the font's going to appear. And \large is the size of the text. And because it's in caps, it's going to be very large. So if we go here, University of Melbourne, it's in that sort of capital letters style, and it's quite large. And we've added a bit more space, and we've done a similar thing with this Aries title here, except it's going to be slightly smaller because large isn't in caps. And you can see there it's a bit smaller, but it's still got the same text format. So that's how you can insert fancy looking Roman-esque titles. And here there are a few more ways to change the font size and appearance. And that ends up looking like this. So you can see it's italicized, which is what IT is short for in this command. And if we don't put our text within one of these braces, then it will just look like normal text. So this lecturer / tutor / supervisor, Dr. John Smith, that's not enclosed in anything. So it just ends up looking like normal text, which you can see at the bottom here. So there's a bunch of different ways that you can adjust the size and appearance of your titles, and make sure to end the title page because every begin has to have an end. Take it away.
All right. So table of contents is super neat because it's basically automatic. All you have to do is insert that one line, table of contents, to be able to have, basically a table of contents. So if you go back to the overleaf.
Yep.
All right. So here you can see the line highlighted here is just our table of contents. We've added a new page into it as well, so that the table of content is isolated. So that new page command tells you that after the table of contents, we're going into a new page where the next section will be covered. Other useful commands are also like new line, which, as it says, it specifies that you want to enter and go to a new line. You can also use double backslash to be, oops, no, it's this one, double backslash to like state a new line as well when you're writing. Both of those kind of work pretty well. Okay, so for the table of contents, for it to be able to identify what a section is, we use the command section here, if you can see there. So there's different types. There's section, there's subsection, and whatever, I'll just call it subsection. And there's subsection, etc., etc. So it goes down. And if you kind of recompile that, you could see that it will automatically indent each of the section and also number it as well. So our first section is 1, and then the subsection is 1.1, etc. And if you scroll up towards the table, oh yeah, that is the table of contents. Okay, now there is a way to not have a section featured on the table of content. Say, for example, you don't want a particular section, like, I don't know, like maybe you don't want the appendix to show on the table of contents, for example. You can use the star command. So in this case, I will define a section, and then I'll put a star in, and then I'll put my brackets in. Now this will say that this won't be featured in the table of contents, but it's also not going to be numbered. So I'm just going to call this appendix, say, for example. And then if you recompile that, you're going to see that it's not featured there. And if you scroll down to the main content, like the main page, yeah, here you could see that I've created a section and it's not numbered in this case, but it's also not included in the table of content. Now, there might be a situation where you don't like it being numbered. but you also want it to appear in the table of contents. So if that's the case, then after your section, you can use the command add contents line, and TOC, which represents table of content. And then you can define what this is. You can either define it to be a section. That's what it is. It could be a subsection, subsection, etc. And then the name that you want it to appear in the table of content. So say, for example, I want this to appear as appendix. So now, if we recompile all of that, and we scroll all the way up, once it's recompiled, we can see that we've got ourselves a appendix, and we've also added the contents as well. Why does it say that? I don't know. Okay, doesn't matter. Yeah, so basically the table of contents is quite easy to work with, and it all comes when you use your section, your sections, and that's kind of how LaTeX is able to break down your file. Okay. In our main content, you can customize a lot of your regular text using different functions. In this case, I think Cas has kind of gone over like the italics, for example, but you could also color it, bold it. There's two different ways to italics it. So you can either use text IT or emphasis, and you can kind of combine them all together to, like, you know, bold and color and do all of that at the same time. So let's kind of scroll down and kind of go through, yeah, this, for example, for our color command, as you can see, it requires the brackets. So say, for example, I want to create another text, I'll color it. And in this case, I'll have to specify the color of it. So that could be blue. And then in the bracket in the middle, that will kind of define what exactly you want to color this. So this could be my text, which is the color blue. And as you can see there, it will kind of specify the color. Awesome.
Okay. Lists.
A good shortcut with bolding and stuff like that, you can actually use Control-B and highlight a text so that you don't have to actually write the function for that. So say, for example, if I've got text here that says I can type anything and I use Control-B, that automatically will bold that section that I've highlighted. So yeah, you can use shortcuts as well. All right, making lists. So there are a couple of ways that we can make lists. Two main ones are numbered list and non-numbered list. So if you can see in this slide here, using the enumerate function, that kind of will classify this to be a numbered list, and all of our items are defined by the item tag. So if we go to Overleaf, and you could see here, we've got the begin and end of enumerate. So everything within here will be a list, and then our items being the first, the second. In that example, you could also nest your lists. So say, for example, you've got a couple of lists, but you want like a second indentation in your lists. You can copy and paste that. So you can go begin, enumerate, and then you can enter your item. So this could be my sub item. and then another item as well. So that will be my sub item. And if you were to recompile that, then you can see here that we've started off with like 1, 2, and then it has indented and then created the second part, which is A, B, so 2A, 2B. We could do that the same with a non-numbered list. Instead of using enumerate, we use itemize. So in this second list here, we can do that exact same thing of like adding lots of bullet points and then like nest our bullet points. So you can have like another nest, and then I'll just tab that, and I don't know, maybe a third layer of nest, like making sure that it's inside the begin section. So here I've kind of nested 3 bullet points, and if you recompile that, you could see them like being indented further inwards. Yeah, cool. So that's kind of the basics of making a list.
Very cool. Would you like to do this one as well? Because you.
Yeah, sure.
Cool.
Yeah. Okay, so making a table can kind of be a bit annoying on LaTeX, not gonna lie. But it's, once you get the hang of it, it's not too bad. And a lot of the time you can actually Google this stuff and then copy like a template table and then paste it in and then edit it. So if you, in this slide, we begin with doing the same thing as a list. Instead, we begin with a table. Now, the square bracket with the H in the middle kind of just indicates or tells LaTeX that you want the table to be inserted here, like in that section of the contents. We can center our table, so that kind of puts it in the middle of the page. And then the begin tabular is where we begin to create our table itself. So to do that, you can see that that curly bracket with the C's and the C's on the side, that defines how many columns we want in our table. So in this case, you've got 2 C's and then the lines in between. So the 2 C's means that there are 2 columns, right? And then the lines will indicate the column lines. I think this might be explained a bit better on Overleaf. So if we go back to Overleaf.
Table.
All right, so I can start by beginning with a table. And the really cool thing is that as you start typing table, the option will kind of show up, and then you can click tab and it auto populates and creates like a template for you as well. So it's really handy that way. And here I say H and I want to center it. And now I can begin my table. Now I can define what lines I want in my table. So here what this would say is there's a column line, and then your column, the middle column line, your second column, and then the end of the line of the table. So if you, or maybe I should like write some stuff first. AA. If you refresh that, Cas. We can see here that there's like we've kind of defined as a column line here. There's our first column, there's the middle column line, and then our second column. Say, for example, we wanted 2 column lines in the middle. We can just indicate that, and then if we refresh it, you can see that there are now 2 column lines. So yeah, that's kind of like how you customize your columns. Now, the second thing to do is to start creating the rows, and this already has populated our first row here. So as you can see, our first row has our first content, and it's broken up with an ampersand to indicate the next column, and then that's the content for the next column. We can tell we can tell Overleaf that we want to go to the next row by indicating a double line here. And that will bring us to the next row, which is over here. Now, you can see that this table here is missing row lines. What we can do is we can add in row lines by using the command H line. So if I put that there and then you refresh it, you can see now that there's a line in between the two rows. Say before I begin my table, I want a line on top of that as well. I can say H line, oopsies, / H line, and then another H line command. So now I want two row lines at the top. And there we go.
Sorry, I compiled it too early, but
yeah,
I'll compile it again.
There should be two after that. Yeah, nice. Okay, so say that's our table now. You can see that there are a couple of commands underneath this table. The first one is a caption. So this is obviously where you caption your table. And you can notice that like LaTeX automatically numbers your table for you. So you don't have to worry about numbering the table. It's all automatic. You just have to like, yeah, change your caption. Say, I don't know, this is a table and stuff like that. Labeling is also another feature that's quite important when it comes to referencing a table. So this here kind of names the table, but it's not for the reader to be able to see. Like the reader can't see that you've named it my table. It's for you. So if, say, for example, you're writing up a document and you want to like reference a table. So you'll say, refer to table something, then instead of writing table 1 or table 2, and then say, for example, when you move your tables around, it changes, and then you have to like change your reference, you can use the reference command instead. So you can use ref, and under ref, you can say table, tab, my table, my label, and then when we refresh that, it will call for that table. Now, the bad thing though is that we've kind of labeled every table to be called my label. So I don't know if we'll reference the right one. Oh no, it does. All right, cool. Yeah, so here it will automatically put in the table number for you. Because say, for example, if I move this table above this table, so now that table I've created becomes table 1, it will automatically change that to say, refer to table 1. There. So yeah, that's the nifty part about it. How are you guys finding that? Like, do you want me to go through another example of tables? Do you have any questions? I'll take silence as no.
We'll take that as a no.
Okay,
Fantastic. Cool. Awesome. And did you want to explain this one, or are you happy with, I think you've explained everything pretty well.
Yeah, I mean, yeah, that's just kind of like another example of your tables. In this case, we've got 3 columns instead, and you can also bold your text at the top to kind of make that like a heading instead. But yeah, it's always the same concept.
All right. So we can also insert figures, which is similar in some ways to inserting tables, except tables are a lot trickier. So Anne has really taken the tricky part of the slides there. So we're going to go through how to insert a figure, and the difference between inserting a figure and inserting the plain old picture that we inserted at the start is a figure will automatically have a caption at the bottom, and it will have a label that you can refer to, just like Anne was explaining with the tables. So what we've done here is we've done begin figure and also put our end figure. As Anne said, when you're typing this, you can press tab and it will come up with a little template. We've centered the image, and we've, within our figure, included the graphics, which was the same command that we used up at the top. We've made sure that our unimelb.jpg is in the correct location, and in the caption command, we've put it to the University of Melbourne logo, and we've set the label here, instead of tab, we've set it to fig Unimelb logo. So we can then reference, like at the bottom here, we can refer to figure blah, whatever it ends up being. And the awesome thing about this is, if you keep adding new images, if you keep adding new figures and shifting them around, you don't have to worry about going through it and checking all the numbers are correct and making sure you haven't stuffed something up. It just does it automatically, which is honestly one of my favorite things about LaTeX. So where did I put that code? I think I put it up here. So this is the same code as before, and we don't need to recompile, but you can see here in this figures section, it's inserted this image, and the width of this image is the same as the text width. So you can see it's really large. If I wanted to make the image a bit smaller, I could type 0.5 here and it'll make it half the size. You can also see that the caption has been added successfully, and refer to figure 1. Well, on line 119 here, I never actually wrote number 1. I just wrote \ref. And as Anne showed you before, it filled in the number 1 for us. So that is the similarity between inserting figures and inserting tables. It's quite simple once you've mastered inserting tables. Another thing you can do is you can have multiple images within one figure. So you can see here, we've said begin figure, and we've within that said begin mini page, which is the command or the name that LaTeX uses for subfigures. I prefer to call them subfigures. And what it's done here is inserted a small version of the Unimelb logo. And if I go back to the Overleaf, you can see that we've just repeated that section of code 3 times. So we have 3 subfigures, and lo and behold, if I scroll down, there we go. 3 subfigures. Okay. And figure 2 has automatically been numbered. The caption has automatically been put there. So that's pretty much all you need to know about figures. In terms of making equations, this is one of the most powerful things that LaTeX is used for. It makes really beautiful equations. And once you get comfortable with typing out these equations, it becomes a lot easier than using something like Microsoft Word's stupid equation builder thing, which is just horrible, slow, like it sucks. But LaTeX, because you're just writing code, it never gets messy like that because you're in full control. And we have an entire section for that. So let's scroll to the equation section, and we'll go through a few examples of the kinds of things you can do. So here's some standard text. And if I wanted to insert an equation within that sentence, I would use these dollar signs. So I've just used a single dollar sign on either side of the equation. And what it does is converts everything within this dollar sign to a pretty looking maths equation. Okay, so we've got x squared plus 3x plus 2 equals 6. And you can see here, it converts the x squared to a nice looking x squared, and it converts all of the style of the letters into nice consistent format. And we can do the same thing using double dollar signs. And what that does is puts the equation on a new line, on its own line. So even though in the code it's all on line 5, you can see that it's put the maths into a new line. Okay. And in terms of inserting numbered equations, which you might want to refer to later on, you might want to say, please refer to equation 3, where we used it later in the report. Then you can use this \begin and \end equation, which will insert a numbered equation. And that's this line here, y equals sine of 5 plus x minus 2. And you can see that it's numbered there at the right. Okay, and every time you insert an equation like this, it'll automatically number it for you. Okay. If you want to remove the automatic numbering, if you have way too many of these numbers at the side and you only want to refer to a couple of them in numbered format, then you can add this asterisk to the equation that you don't want numbered. So for z equals x squared plus y squared, I've added an asterisk at the begin and end. So instead of equation, we have equation star, and that removes the numbering, which is similar to adding the asterisk for subsections and sections. If you don't want that numbered on your table of contents, then you would add an asterisk. It's the exact same thing. You can see for that equation, z equals x squared plus y squared, there isn't any number. And another thing you can do is align the equal signs if you have multiple equations that you want to compare directly. You can see here for this a equals b section that normally these equations would be very misaligned and it'd be hard to compare them. But if we put everything inside a line group instead of an equation group, then we can add multiple equations and all of those equal signs are aligned. It's worth noting that this numbers all of those equations as well. Okay. If we put an asterisk here, it wouldn't number any of those equations. And another thing you can do is if you want to insert a long derivation or lots of maths at once, and you don't want to have to type begin equation a bunch of times, you do this thing called begin multiline. It's actually multline, which I don't know why they chose mult instead of multiline, but it's multline, and that allows you to put in as many equations as you want. This wouldn't work if you just did equation, unfortunately. It works if you use multline though, and you just do the 2 backslashes in red here to indicate that you've gone to another line. And I've used centering here to center all of these equations, and all of these equations are put into one group here. Let's analyze a bit of this code because this is the real nitty-gritty stuff on how to actually write your equations out. So a equals b, that's pretty simple, pretty self-explanatory. This next line, we've got subscripts and superscripts. So use an underscore after a variable to give it a subscript, and use the up arrow to indicate a superscript, i.e. a power. And you can see we've got x subscript a and x subscript b squared. So you can use the underscore and the up arrow together to give you a variable with a subscript and a superscript at the same time. However, LaTeX will automatically only add one letter to your subscript. So if you want to insert a subscript that is longer than one letter, let's say you just tried x underscore subscript here, and let's recompile that and see what happens. What LaTeX is going to do is it's going to read x underscore s, and it's going to finish the subscript after the letter s. And then the rest is going to be ubscript, but in big text. So if you want to have multiple letters in your subscript, you have to enclose your entire subscript in braces. And now what will happen is it will treat the entire word subscript as the subscript. The same applies for superscripts. So here we have x to the power of airframe, could be anything. And you can see that the entire word airframe is up at the top. If we didn't have those curly braces there, then that wouldn't work properly. It would just do x to the a, and then frame would be in big letters afterwards. Another thing you can do is subscripts and superscripts, but to the left of the variable. For example, if you're doing a transformation matrix from frame 2 to frame 1 here, you can see it's the exact same, except you put it to the left of whatever letter in the code. So we've got T subscript 2 to the power of 1, but it's on the left. Another really nifty thing about LaTeX is that you don't have to search a toolbar for different symbols, like Greek symbols that you might use a lot, like theta, gamma. Those in Microsoft Word, you have to scroll through a big list of them to find the one you're looking for, and it's a real pain. In LaTeX, you just type backslash and then the name of whatever you want to see. So backslash pi, backslash alpha, there it is. Easy. And, oh, what did I just do? 1 second. So another thing you can do is lowercase and uppercase letters, symbols. So we've got a lowercase delta with a lowercase d and an uppercase delta with an uppercase d. So lowercase delta is here and uppercase delta is that triangle. And that works for any of the Greek symbols. So I could put uppercase alpha and it would change to uppercase alpha or uppercase omega, whatever you want. Another thing that's really common is trying to do fractions. And again, in Word, this is a real nightmare because you have to type that thing that puts the 2 empty boxes and then you have to click on the top box, type. It becomes really horrific. In LaTeX, you do backslash frac and it takes 2 inputs. The first input is whatever's above the fraction and the second input is whatever's below, i.e. the denominator. So we have x on y is just with frac xy. And there's another example of a fraction there. This is an example of a fraction which has some symbols inside it. So this partial symbol is that curly d. And you can see that you can use all these functions within each other and they're all compatible with each other, which allows you to really easily build complex looking equations. Here we have, okay, this is an interesting one. So we have a fraction, and what have we got? Oh yeah, backslash square root xyz in brackets. Sure. Let's look at the line below that. This one's pretty interesting. You'll see that we have this backslash left command. And what that does is create a left bracket, but it matches the size of that bracket to whatever's inside. So if I got rid of that word left and just did a standard bracket, the bracket would be really small compared to this fraction. It wouldn't match the size of the fraction. You can see that this fraction is now a lot bigger than the brackets. So to insert brackets that actually suit the size of the thing inside, just type backslash left bracket and backslash right bracket, okay? And again, inside that, we've got this fraction with a function inside the fraction. You can see you can use all these functions within each other. You can also insert mathematical symbols such as greater than or equal to, greater than, lesser than or equal to. All of that stuff is available. You can just Google it, like LaTeX lesser than or equal to, and it will tell you it's probably backslash LEQ or something. And you can do integrals with this backslash int. You can determine the limits of the integral using subscript and superscript that we discussed earlier. So we've got from 0 to infinity here. And then whatever goes inside the integral, you can just type afterwards. So there's heaps of different options. You can also put dots. This is really useful if you're working with velocities or accelerations or anything that's a derivative with respect to time. Just put \dot and then the name of the variable. Okay. And I could add _m to that. I could add whatever I wanted to that. You can do double dot as well for second derivatives. And just one more example of what you can do with equations. I know this is a lot to take in at once, but it just shows you how powerful LaTeX can be. You can also add matrices. So we've moved to a new equation block here. And we've got a matrix equation by inserting this begin matrix and end matrix within our equation. We've got this capital B here to represent, it's a brace matrix. And you can see that x1, x2, x3 matrix or vector is in fact enclosed in braces. And then you've got this lowercase b, which represents square brackets, okay? And it's the same format as for a table. So you do a new row with 2 backslashes and you do a new column with an ampersand. So if you're familiar with building tables, then building matrices should be a piece of cake for you. And that is just scraping the surface of what LaTeX can do. It can do anything mathematical that you want. There's so much that it can do. And I know that was a lot, but there's a lot to say. So, whew, okay, your turn.
Nice. Okay. So we kind of said that it could insert MATLAB in a really easy way. And the package to do that is the MCode package. So you basically just copy and paste this use package line and put it at the top of your document where all of your packages belong. And the second thing that you need to do is also to have an mcode.sty document. Now, if you follow that link, that will send you to where you can get that. But once you get that mcode thing, yeah, so it will be contained in here, and I think you can download the text for that. But if we go in our Overleaf and you click on the mcode.sty, it's just this standard file. You would copy and paste this whole thing and rename it. So basically I'd create a new file, which you go from the top right corner, and then you would name it mcode.sty. And then all you have to do is copy and paste this text into that file. And that's how you create an mcode.sty. So now that you've got the package and that, all you need to do now is, oh yeah, thanks Max. All you've got to do now is put the MATLAB code into a folder. So here we've kind of created a folder called MATLAB, and we've copied and pasted like whatever MATLAB code you want. Make sure that it's a .m file. God, lights have turned off. Workplace is like telling me to leave. Okay, and so if we go into our appendix section where we want to insert our MATLAB code, it's super simple because it's literally one line of code to do. It's all you have to do is go lst input listing, and then you write down the directory, which is MATLAB, and your slash and the name of that MATLAB code. And that will automatically insert all of the code in there. So we can do one together just to make sure that everyone kind of understands. Say, for example, I'm going to go for a new page, and I'm going to insert a subsection. and call it Appendix B. And that's just like the heading for it. And then now all I have to do is insert that MATLAB code in. So lst input listing, and then it's just the directory name, MATLAB, and then the code name. So q3.b.m. And then when we refresh that,
That's a big code.
yeah, I don't even know whose it is, but you'll see that it's all inserted automatically and with very nice formatting as well. Alternatively, you can copy and paste code into the text editor as well. So instead of uploading your MATLAB code, we can insert that by using the begin list listing. So here, I'm going to create a new page. Oops. New page. And then subsection. And then I go begin, right? And then it's lst listing, and then making sure that all of my MATLAB code will be within this area. So I'm just going to copy and paste, I don't know, this thing here. And then I'll just paste that in. And now when we refresh it, you'll see that we've kind of hard coded it into the appendix. So yeah, two really easy ways to like insert MATLAB in without having to like screenshot your MATLAB code and stick it in Word document.
Just a reminder that to do this, you need this line, use package mcode.
Yeah.
Mm-hmm.
And also the mcode.sty. And then that should do everything for you.
Okay. We'll go over this fairly quickly because we're going a little bit over time. But we're going to talk about how to make a bibliography. So again, LaTeX has a lot of tools for automatically formatting your bibliography, which will make your life easier when you have a lot of references to deal with. The first thing you can do is use the package bib.latex, and that just goes up near the top of your code. And then you add this file called bib.bib, which is your bibliography file. And the bibliography file has a list of your references with information about them. So I'll show you what that file looks like. You can see here we've got an article as a reference, and we've called that article Walker. This is like our label that we could reference in our text. And we can add various information about that reference. And I won't dig into that. You can look at that in your own time. But you can see here that we haven't numbered our references or anything. We've just put them in and given them a label. And then LaTeX will automatically, it'll be above all this appendices, but LaTeX will automatically format the information there. Okay. So you do these two lines, use package bib.latex and add bib resource. And then to actually insert your bibliography, you go to the bottom of your text and you just do this line. These two lines here. Add contents line will just add the references section to the table of contents. I can quickly scroll up to show you that. So if I didn't add this line, then the references section wouldn't be listed in the table of contents. And then the line that automatically adds the references is print bibliography. And once you do that, it does this. And you can reference using a command backslash cite. And you can see here it's got a list of references. So I might want to cite this one. And I could say, according to /cite this. And what that will do is, if you had a numbered reference list, it would automatically choose the correct number. Or depending on what format you want to choose for your referencing, it might just say, according to Matsarakyo, however you say that. And you can do that just like we did with tables and figures. You can just make references to it, but you use cite instead of ref. That's the only difference. I think that's all we need to say about making a bibliography as well. And yeah, that's all there is to it.
Yeah, awesome. So yeah, we've got that template, and we're happy to like share that around for you guys to like download, copy like all of the packages, and like use it as like kind of like a template whenever you need to like create documents in the future. But yeah, hopefully you guys can use all of this to be able to create beautiful reports for Aries in the future. Next week, we'll be covering Onshape, and this will be kind of like basics of Onshapes, and we'll try and create wheels and stuff and a cup together. And hopefully the session afterwards, we can start catting up our rocket. So the nose cone and the fins and things like that as well. So yeah, that's going to be pretty exciting.
Awesome. Thanks for coming, everyone. Cheers.
Thanks.